Okay, let's demonstrate the chain example. This is loosely based on the official examples. When we go to the chain with 4 rigid links, we'll see it specified, and it looks something like this. 4 links connected to a ground and then looped around. So let's build it up real quickly and demonstrate it. We'll enter Blender, and first thing we'll do is add some gravity. So we'll add environment, gravity, vector, new. This will have a scale of 9.81, and it will be in the minus z direction. This will be driven by a unit drive, so it'll always be operational. Gravity will be. So now let's take this object here and make that into a joint, a clamp. And that will be our ground. From the ground, we'll offset by 1 unit to the x direction. So that's our offset. And now let's look at this from the side, and we can see that's where we'll begin the chain. So if we add a body, which will be the chain link, we can give it a inertial properties of, well, if we make it diagonal, we'll see that the chain inertial properties are 1.1, and this comes right out of the example, 0.01. That's represented here as this chain link, and now we can move this. We'll grab it to the x direction 1, and then we can rotate it about the this 3D cursor. Let's go over here, 3D cursor, and rotate it 45 degrees. So there we go. Now itself will rotate it about its origin, individual origin. We'll rotate it minus 90 to make it vertical, and then we'll need it to go rotate half of 45 degrees, which is 22.5. Now the one other thing we need to do is place it midway between here and where it's where it's to be connected. So we take these two, and we'll let's see, have the cursor go to the selected items, which is here, and then move this to the cursor. Okay, so now we have the chain link in the right orientation and in the right location. We will connect it via a revolute, a spherical hinge. Here we go. And we are ready to simulate this, at least the first link, so we can just make sure everything's going well. We'll run the simulation, and we'll show each of 100 steps for the 10-minute simulation. There we go. Right. Now, we'll make 4 more of these for the 4 links, so we'll take these 2 objects and we will duplicate them, except for the rigid offset, and then we need to move the cursor back to the center, and then we'll rotate everything about the 3D cursor. So we rotate 45 degrees. See here. Here we go. And now we'll take both of these, and we can duplicate this again without the rigid offset. Rotate through 90 degrees. And now we have all 4 links. We just need to connect them and then simulate it. So let's take this, and we'll connect this through a rigid offset. Likewise here. And then 1 more. Alright, so now we can simulate and watch this run. Sure enough, there goes the chain links. We can now take each of these links, put them in their own layer, which will make visualization a bit easier. So we'll go over here, and then we can look at it this way, and we can watch them. Now if we notice, they're not really oriented the way chain links would be. We should rotate these. So we'll go about the individual origins, rotate about the local x-axis 90 degrees, and now that looks a little more like what the chain link should be. So with that, we can again run the simulation. And let's go back here, animate the objects, and there we go. Okay, so now that's a little lively because there's no damping in the joints. But before we add damping, we need to relieve all the stress. This is not really in its low stress condition. It's close. The way to do that is to connect this link to the ground initially and allow all the stress to be relieved. So we'll do that by adding a rigid offset here to the ground in the -1 direction, and we'll rotate this 90 degrees. That will be the inline joint location. Now this will give that also a rigid offset. Okay, and that, let's just take it here and move it, and then we can grab it -1. Now it's where it needs to be. So we'll connect that rigid offset of the chain to this one, which will be the inline joint. We'll add the inline joint, and now we can simulate again. Okay, run simulation, and we'll see. We animate the objects. Again, just go back and look at this. There they go. Now, again, it's a bit lively. We need to add some damping. So we'll add some damping at each of the joints. We have a nice feature of filtering out the elements to only those of a particular type. So we'll go for the spherical hinges. And at each hinge, we can add a let me see here. We need to see everything here. So take this hinge. We'll add a joint, let's see, a deformable hinge. And we need a 3D constitutive of a linear viscous type. Make this 3D, viscosity of 1. So there we go. There's our first one. Well, now we'll add the second one, joint. Let's see, a deformable hinge. Again, okay, we'll do the third one, add, joint, deformable hinge, and then one more, add, joint, deformable hinge. Now, let's see. Here it's saying that we need to play with the derivatives coefficients. So let's go take a look at that. And we can do that by editing here, looking at the general data in the simulation. And let's change this. Its default is 0.1. Let's change 0.001. Let's change it to 0.1. And now we can run the simulation again. Good. Hooray. It's running. All right. Now let's go back here, and we can animate our objects. Now let's look at what happens. Ooh, nice. So all of that stress is relieved. Now there's a couple of ways to do this. What I find to work best is to take the end of this simulation where all the stress is relieved. Right, so we have, again, if we go back and we look at this, we can say, okay, see, we're relieving the stress. I'm going to take that as my initial condition, and the way to do that is to go select all of my objects and delete the animation, right? And well, let's see here. Let's see. Let's try this again. Let's go back here. Let's make sure. Let's see here. I'm going to animate them again, just to make sure. Okay, so I'm going to go here, and now if from here I delete the animation, right? Okay, so I have the animation's cleared. When I go back to the beginning, all right, now if I rerun the simulation, so I start it from here, rerun the simulation, it's starting from a relieved condition. So when I animate, it really ought not move at all. And let's just make sure that's the case. Nice. Okay, so that's good. So, next thing I can do, and I will do, is we'll just remove that inline joint now. We no longer need it, so we'll get rid of it. Just delete it. And if we now run our simulation, wait, I'm going to do it one more time. I want to give this a little more. It looks nice at this point to run a little longer. So we'll do that. And we're just about done. We're going to run it again. Okay, it takes a little longer to run this time. But here we go, and then we can animate. And take a look at this. There we go. There we go. Right. And that's our chain with damping. Very nice. Now, let's look at one more thing. Look at some of the graphs that come out of this. So we can look at the motion of this node. And that's that node right there. So let's look at its x position and its z position. There we go. X and z over time, over the 20 seconds. Another one let's look at is the, let's look at the, that spherical hinge, the first one, which is up here. And we can plot the physical attributes. We can plot the moment about the y-axis. That's the one from the damping. And, I see it. That's not the one we want. Let's plot not the spherical hinge, but the deformable hinge. There we go. We'll plot its moment. Plot the moment about the y-axis. There we go. That's the moment due to the damping. And there's quite a number of other plots you can do on forces and moments for any of these. So that is a complete demonstration. I hope you're able to learn something and make use of the tool. All right. Thank you. Bye-bye.